So the first command I want to go over is called ipconfig. It is a Windows command, and it has a counterpart in the Unix world, so that you'll see a similar command on any of your Linux machines, as well as any of your Mac OS X machines in which you run the terminal application. And I'm going to go over both of them here because they often get confused. And even I myself type the wrong one into the wrong system. So we're going to go over the first one, which is ipconfig. Not to be confused with ifconfig, which we're going to talk about in a minute. But ipconfig is strictly a Windows network utility. And for the most part, it is descriptive. It is typically used to get information about a system. So if I just have run command.exe and I start out by saying ipconfig, Windows returns all of the basic networking values that it has been configured with. So in this case, what you see in front of you is the output of ipconfig. Windows has parsed through all the different network interfaces on this particular system that I'm running the chat session from, and it's giving me information about how they've been configured. And the information is pretty basic. So it starts out by telling me I have a wireless LAN adapter, and that the wireless LAN adapter has a particular IP address, 10.10.5.100. And it tells me its subnet mask, and it tells me its default gateway. And it does the same for a second interface on this system called the local area connection. Or this is the wired interface. So for the wired interface, it's telling me basically that I'm on the same network. It has an IP address of 10.10.5.230, same net mask and same default gateway. But what I wanted to point out here is the ipconfig command in Windows is not what I call a verb. It's not doing something. It's merely reporting back something in this case. There are some situations where we can get ipconfig to do things for us, but what a lot of people get confused is they expect ipconfig to be able to configure a network interface. And it was never intended to do that, and for whatever reason, Microsoft has never made configuring an IP interface from the command line easy. So ipconfig is what I call a descriptive command. Tell me something about the system. I'm not necessarily changing something about the system. Now I can get more information. If you can see at the bottom of the screen, I'm typing ipconfig again, but this time I'm going to add a switch. And a switch, for most Windows commands, is telling the command to do something specific. It starts with a / and then the name of the switch, which is, in this case, is all. Now, all is going to do a very similar thing that I just did a minute ago, but it's going to give me a lot more information. In fact, it's going to give me so much information that it scrolls past my screen and I can't read it all. Since the command shell has a scroll bar, I can scroll up and down and review that information. But one thing you're going to want to know how to do is to direct commands to another command called more. And more is going to enable, what you might call paging. So that if the output of the command is too much to fit on one screen, the command shell will automatically pause when a screen is full and wait for you to hit the space bar before it presents another screen full of information. So what did ipconfig all tell us that we didn't know before? If you look closely, you can see that it tells you a lot more about those network interfaces. It tells you not just your IP address, subnet mask, and default gateway. It tells you the full description or text string that describes that interface, which is something you're going to want to know as you get more advanced using the Windows command line. It tells you the DNS server. It tells you the DHCP server that gave out that address. So typically when the all switch is being used, I'm going to type that out again, ipconfig/all, and because it gives so much information, we pipe it to more. When that all switch is used, what we're typically looking for is the DNS servers. That's something that the plain old ipconfig command doesn't provide, and because we want that extra information, we're using the all switch. So that's a lot about ipconfig, and as I said a few minutes ago, it is not to be confused with the ifconfig command, which is found in Linux, Unix systems, and Mac systems can use this as well. So ifconfig is similar. It's not exactly the same. ifconfig is used not as a descriptive command, as I call it, but more as an action verb command. ifconfig will actually configure the interfaces on a system. It will take the interface up and down. So if you have it configured to be a DHCP client, this is a good way to reset that, purge the old address, ask the DHCP server for a new address. So this is a Linux system. ifconfig does the same thing, very similar thing as ipconfig if it's run just by itself. But it can also tell one of these interfaces to be taken up or down. And as I said, that will reset the interface and prompt it to get, if it's configured as DHCP, prompt it to get a new address. So this is something you would use on your network probes that CNE has set up for you. If you need to configure the interface with a static address, or you need to bring up a second interface because you're going to collect packets for something like NTOP or Wireshark. Okay, I'm going to bring up my chat window just for a moment. So if anybody wants to grab a sip of coffee, I just want to make sure I have chat enabled if anyone has any questions. Okay. If not, I'll keep going. So we're going to continue with the networking theme. The first command that I have that's for Windows and for all systems really, that's again one of those action commands, is ping. Ping is a way for you to test whether or not you can reach another host on your network. It tells you a couple things. We primarily use it to make sure we have connectivity to another host or another destination. But when we run the command, we also get some other information. So we're going to take a look at that. So I'm going to run a ping to a host on my network. And it's a host that I have connectivity to. And I know that because I got replies from the host that I sent the ping commands to. As opposed to if something were not on my network or not reachable from the host that I'm running the ping command from, it would attempt to send and receive replies. It would wait a specified amount of time to get those replies, but they would eventually time out, as you're seeing here. If you get tired of waiting for it to time out, you can hold down the control key and press C, which will break out of that command set. So in the first case, I had success, and in the second case, I failed. In the first case where I had success, I'm going to run that again. It's telling me I can reach that host because I get a reply. It sent 4 packets to that host. and of a size of 32 bytes apiece. And then it also tells me something, a couple other interesting things about that test. So if we look at this, more than one thing was reported back. Notice that, as I said, we sent a bunch of packets to a host, 10.10.5.1, and we sent 4 of them. They were of size 32 bytes apiece. Ping also calculated how long it took for the reply to get back. And then it also told us how many routers deprecated that or reduced the time, how many routers it had to pass through to get there. Since it started with, since the reply started with a time to live of 64, they didn't pass through any routers to get back to us, so they remain 64. But what's interesting is this value, and you may find this useful when you're diagnosing a network problem. Ping actually tells you something about the speed of your network, or at least it tries to. It has this calculation it's doing based on when the reply came back from the host, and it's reporting it back to you in milliseconds. It's a very brief test, so it's really more like a snapshot of how that particular link between you and that remote host or the host that you targeted, how well that's performing at the moment. But it's not a bad way to diagnose a problem when someone tells you the network's slow, because Ping does try to tell you, look, I not only can reach that host you targeted, 10.10.5.1, but this is how long it took for the packets to get there and come back. And when you're working on a network problem, you may want to use Ping just to make sure you have connectivity and the network's working reasonably well. Ping also has a switch, -T, just a dash sign and a T, that if you put it in front of the host, it won't just send those 4 packets. It'll continue to send them until you hit Control-C to break out of it. And when you're configuring your network, you're setting up a router, you're setting up switches, this is a good way to make sure you haven't broken anything. And that whatever you're doing hasn't resulted in the loss of connectivity for anyone. So similar to Ping is a command called traceroute. And I've written it twice up here because everybody calls it traceroute, the full word, or 2 words tied together. Windows, for whatever reason, abbreviated it. What traceroute does is it's similar to Ping. It sends very similar types of packets to a remote host, but rather than just report to you whether it can reach that host and whether or not you and what the latency is to get there, traceroute tells you how it gets there. So it's actually showing you, look, between you and the remote target that you specified, in this case I wrote 4.2.2.2, these are the routers I'm passing through, and this is an estimate of the latency that it takes to get to each router. So what does traceroute offer you that Ping doesn't? Traceroute can actually show you that maybe you have a bottleneck somewhere between you and the remote host, and it can help you diagnose that problem by identifying that bottleneck. So a couple things to remember. One is Microsoft, unlike anyone else, abbreviates traceroute as just 7 letters, not the full 2 words traceroute. The other thing, you may have noticed how long it took to run that test. Always remember when running a traceroute, if you're not concerned about the names of those routers and those endpoints along the way, use a switch called -D when you run your test. And -D will tell traceroute, don't bother looking up the names, because every time you look up a name, you have to query a DNS server. And it doesn't change the results in terms of the latency that it's reporting back to you, but it does take a lot longer for the test to finish. If I run that same test without resolving names, well, sure, I lose the ability to see the names of the routers along the way, but that's not a particular concern to me. I just want to see the performance results. And so traceroute-D allows me to do just that, run the test without resolving names. Any other type system, again, here's our Linux window. It's the full 2 words, traceroute. And if we don't want it to waste time resolving names, just about anywhere else you use the traceroute command, you're gonna say -n, no names. Microsoft had to be different in 2 ways. It abbreviates the term traceroute, and disabling the looking up of names became -D in Microsoft's world for some reason, and you won't find that anywhere else. So in that same vein, when we're diagnosing a networking issue, we have a command called pathping. Pathping is a Windows-only type command. We use it the same way as we do traceroute. It does essentially the same thing. But remember we said that traceroute gives us a nice estimate of, as well as ping, gives us an estimate of how our network's performing by measuring the latency between ourselves and that remote host. Pathping does that as well, but it does a better job. So pathping, if I don't want it to resolve names, whether, well, this command only exists on Microsoft. In this case, it uses -n like everyone else does to not resolve names. But it's going to create, it's going to measure, just like traceroute did, how many hops it takes to get to the remote host. But notice it's what it says at the bottom. It says it's computing something for 5 minutes. Rather than just give us that snapshot at the moment how our network's performing, which may or may not be accurate. You may have noticed a minute ago I got very different results when I ran traceroute a couple times. Pathping is actually going to compute to send multiple ICMP packets, 1,000, to each hop along the way and give us a statistical average of what the latency is to and from each of those hosts along the way. So again, we get that path. We get to see how each router is performing along the way, but we get a much better estimate of what that latency is than the estimates that are offered by ping or traceroute. So I'm going to let that brew for a while, because 5 minutes, and we're not going to sit here for 5 minutes and wait for that, but we are going to go back to it. In the meantime, I want to talk about another network utility. But while ping and traceroute and pathping all had a similar function, they were all testing connectivity. They were all giving us some performance results as part of that test. nslookup does something completely different. It's part of the presentation because it certainly falls under the topics of command line utilities that are used for networking, but it does something completely different. It is not sending packets and measuring any kind of network performance or connectivity. nslookup is telling you, giving you DNS results. So I'm going to do a very simple example. Can't use that shell because it's performing the pathping test. Excuse me. So instead, I'll just clear the screen. And I want to know if I'm able to resolve a domain called Pepsi. Excuse me. And nslookup told me that it was able to resolve it. And it gave me the results. And I'm going to bring them up in another window. So what did nslookup tell us? It's telling us that it used a local host as a name server, and it looked up the domain pepsi.com right there, and this is the result it got. So what does a simple nslookup command do? nslookup command, first of all, tests your DNS to make sure it's working. If you get no reply for any host or any domain, then you know you don't have DNS working properly. But nslookup also tells you what the answer is. So the purpose of DNS, as you probably know, is to convert host names and domains into IP addresses. But you don't typically see that going on when you're browsing the web. Your web browser sends a command up the TCP food chain, the IP food chain to the DNS process, and a query is sent, and the result comes back so that your browser knows the IP address of where you're trying to get. But you don't see that going on when you're using a web browser. So nslookup shows you how that process is working and whether or not it's working and what kind of results you get for a particular host. You might want to have a different result for a DNS lookup when you're on your work network than if you were accessing your network remotely. Let's say you were at home or at Starbucks. In a typical case, you might have a web server and it sits on your network in your office, and you want users that are on your network to access the web server locally through its local interface, but you want remote users to access the web server through its outside interface. And obviously it's public IP versus a local IP for your local users. You would configure DNS to then provide different answers to users based on whether they were local or remote. It's often called a split view DNS. How do you know whether that's working? nslookup is a great way to test whether that's working. If I'm local, I can simply do an nslookup command for myschool.org, whatever your local school network is, or your local school's web server. And what nslookup does is it uses your local DNS server to provide an answer, and it tells you what that answer is. But what if you want to know how does that answer get reported to a remote user? You could tell nslookup to look up that same host, but don't use my local DNS server. Use a DNS server that's out there on the internet somewhere. And you can specify that right on the command line. And nslookup will then, as you can see, it uses the remote DNS server and reports back to you, this is how remote users see that domain or that host name. So nslookup is a great tool to make sure DNS is working properly, both on the inside and the outside of your network. Okay, I'm going to move on. Just want to make sure I'm not leaving any questions behind. Okay. Netstat. Netstat is a different command than any topic we've covered thus far. It is cross-platform. You'll find a variation of it on Windows, Linux, BSD, Mac. It's a very helpful, very useful command. You don't hear about netstat very often. So if you are troubleshooting a problem and you Google the problem you're having, which is something we all do all the time, you don't see people refer to netstat very often. They might tell you to, if you have some kind of connectivity problem, they might tell you to use something like Wireshark or things like that. When in fact, netstat could give you some basic information very quickly and very easily. So what does netstat do? What I use netstat for, I won't go over everything it does, but what I use netstat for is to figure out who is connected to me. So netstat shows me my network connections. And it also tries to use DNS. So we're going to use that N switch to tell it not to use DNS because that just makes it go too slow. These are all the connections I have right now on this system. It tells me a local address. I'm going to bring this up on another screen so you can see it better. There we go. It tells me a local address, which is me. It's always me. It tells me the foreign address that I'm connected to and the IP address of that foreign connection, but it also tells me the port number. So when I have a machine that's a laptop, let's say, that someone hands me and they say, you know, it's running slow all the time. After I'm online for a few minutes, it starts to slow down. One of the first things I will do is run netstat. And I'll tell netstat, as I did up here, just the -n switch, don't resolve host names, but show me what this laptop is connected to. And then I'm going to be concerned for anything that's unusual. Now, 443 we know is SSL, so they're using a web browser, and so is 80. That means they're using a web browser. But I get concerned when I don't recognize port numbers that I'm connected to. And so what I tend to do is I tend to look them up and try to figure out what those are, because netstat is one of the best ways to find malware. When a machine is infected with malware and you run a netstat command, you will very often see connections to remote hosts on strange port numbers that are just not typical. Now, 5228, the last one I circled, I know that that's part of Google Chat. So I'm not terribly concerned about that. But it's something that I will look up whenever I see connections that I think that shouldn't be there. So there's some other neat things that netstat does. I'm just going to mention them real quickly. You can, as I said, you can tell netstat to not resolve names. You can also tell it to report back the process ID and the ownership of the software or the application that's causing that connection. So notice here, when I tried to do that, it said, look, you require elevation privileges. So I'm going to go back and run as an administrator a new command window so that I can run those B and O switches. And I'm going to pipe it to more so that you can all follow what's going on. So this is really neat. Look what netstat did here. It not only reported what kind of connections we're having, but it also told me what application is causing that connection. So my Google Chat is running through Chrome, so it's understandable that this 5228 is running through the Chrome process. But this is where I find malware. When I use the B and O switch is the owning process ID, if you want to have that on there. So this command was run, to make that clear to you, netstat -n -b. Show me the connections and the process or the application that is causing them. So in my next slide, I have a command that sounds similar but does something completely different. Don't ever confuse netstat with nbtstat. nbtstat is strictly a Windows command, and you are getting net BIOS statistics from it. So how do I use an ntstat in a typical environment? A lot of times somebody on the network is doing something they're not supposed to. And what we do is we set up some logging on the firewall, and the firewall tells us, well, there's an address that we found that is violating our acceptable use policies, and it gives us an IP address of that user. So nbtstat is a great way with a switch that is a lowercase a to try to find out who is the owner of that machine. nbtstat-a with the IP address uses the Windows NetBIOS protocol to try and resolve that IP address to a useful name that you can track down. In this case, it's me. So nbtstat, not to be confused with netstat, because it does a completely different set of tasks, but the two do get confused very often, so I put them back to back in this slide presentation. Another Windows command, a command you'll actually find on all kinds of systems, but one of my colleagues suggested adding it as part of this presentation. You want to pay attention to the Windows routing table when you have a server on your network, particularly if you have a server that's multi-homed. Windows has its own routing table. It collects information about routes, assigns metrics to them, and develops its own internal routing table. Sometimes you want to be able to see that, and a lot of people don't realize you can see and even manipulate the Windows routing table. So again, piping it to more so that you can see everything that scrolls past the screen. When you say route print on a Windows machine, it tells you what its routing table is. I'm going to bring that up here. And what I pay particular interest in or to are these that start with 0, all zeros. These are the default gateways. Why do I have 2 of them? Because you might remember before I had a wireless interface and a wired interface. And it's telling me that right here. It even identifies the interface by IP address, not by name. Windows, very often when a laptop gets unplugged wired, Windows hangs on to the default gateway that was provided by that wired network. And you may want to delete that. And there's a very simple command to do that in using the route command that allows you to delete a route so that it's only using the appropriate interface as its default gateway. Similarly, if you have a multi-home server, you may want it to use a special path for local users. You can force it to use a route without changing the routing table for your network overall. And you can specify that this particular Windows host has to use a particular gateway for your local users. You do that in a similar way with the route command, although obviously in that case it's route add. If you type route with no switches at all, you get the help menu so that it explains how to do what I just described. Okay, a couple more that I want to go over because we're getting close to the end here. A lot of what I talked about is old school stuff, and I didn't want today's session to be entirely about old school stuff. So I thought, well, you know, on the Windows command line, and this slide here does pertain only to Windows. You know, what is kind of new and what's kind of cool. And what I have been having a lot of fun with lately is the netsh command. It's clear to me that Microsoft intends to use netsh, which interacts with the PowerShell API, but it intends to use netsh for a lot of administrative tasks going forward. It's hard to get good information on it, though, because it's almost as though it was originally intended to just manipulate the Windows firewall. I mean, that's at least the impression I get. So if you Google netsh and you ask for examples and things like that, you almost always get a long list of examples that have to do with the Windows firewall, turning it on or off, opening a port, allowing a new network access or things like that, enabling an application, let's say. But oftentimes, when I'm trying to find some information about a Windows system, I come across this netsh command. It does a lot of really neat things. So I'm going to close with this because the story behind me learning about netsh and realizing that it really is kind of the future of networking utilities on Windows systems is I'm often working in wireless environments. And as a lot of you know, the wireless LANs have two spectra that they use. One is the 2.4 gigahertz and one is the 5 gigahertz. And it was many times when we buy access points for a wireless network, we have a choice of purchasing either a 2.4 radio or a 5 radio, but many access points come with both. And when I don't have a controller-based wireless LAN, I often want to make sure that at least some of the users are using each of those radios. And so I set out to try to figure out, well, how is it you find out? How do you get a Windows system like a laptop to tell you whether or not it's using the 2.4 radio or the 5 radio? And it's not an easy thing, but it can be done with netsh. And so that's how I discovered this command, and I started looking at all the different things that it could do. So it works like this, netsh. It takes switches that don't have slashes or hyphens, and unfortunately, there isn't real good documentation on this, but I just want to show you one, as I said, that I use a lot. Wireless LAN show all. What does wireless LAN show all do? It presents a ton of information, everything that your laptop has ever seen or done with regard to wireless. So I'm going to pipe it to more so that we can handle it a little bit at a time. But it shows me every wireless card, every driver, every SSID that I've ever used. But it does something that was kind of magical for me that I was not able to do anywhere else on the command line. It provides this value right here that I'm going to try and circle. It tells me the channel that my wireless interface is using. So here's this really cool command that Microsoft has buried in the command line. And it holds a lot of really good information. But it holds one particular piece of information I couldn't get anywhere else. It tells me that I'm on channel 157. So if you know a little bit about wireless, you know that anything greater than 11 in North America means you're using 5 gigahertz. And so this, and now I'll probably get 100 emails from all you guys saying, well, there's other ways to find the channel. But I was never able to just sit at a command line and when I had sat down at Starbucks or in any kind of remote network and figure out, is my laptop even using 5 gigahertz? To be honest, I first discovered this when I bought my first 5 gig router. And I wanted to see if the systems in my house were actually using the 5 gigahertz side instead of the 2.4. And of course, there's ways to configure the driver to prefer the 5 gigahertz and stuff like that. But there was never any way for me to verify. So there along comes netsh. And it does a lot of really neat things. I think it is the future of command line network utilities, at least on the Windows side. And I thought I'd include it here, just to give you an idea of what the future looks like. So we had about 9 topics. We had about 45 minutes. We said that if we spaced them out at 5 minutes apiece, it would work out perfectly. And I said nothing ever has that kind of precision, and that was the one thing I was right about. it didn't, we're a little bit over time. So I'm going to stop the screen share. And I'm going to go back to the chat window. I hope everyone sees the chat window. And good, I have someone typing. That makes me feel a lot better because at least at least I know you can all see the chat window. If you want to use the chat window, that's great. I'm going to stay online and listen to your questions. Yeah, I turned the share, the screen share off a moment ago. Oh, did I ever show the path? Good, excellent. Let's go back to the path thing command. Let me find it. Give me a second. I hope I didn't go right over it. Let me see if I can find the path thing results. Thanks for that question. I hope I didn't write right over it. I'm going to start another one just in case. And I've got an example of the path ping in the slides. So if for any, well, I don't have the mass computation as part of the slide, but I'm going to run the command again, and I'll share this again so that you can see it. And okay, so a couple people asked that question. Let me share my screen. And I'm going to let that compute, and I'll leave this on so you can see the results that come up. So again, what is path ping doing? Initially, as you can see, it does the same thing as traceroute. It sends an ICMP packet to the remote target. But unlike ping, it actually forces every router to send a response. And if you're interested in how it does it the same way that traceroute does. People often ask, how does traceroute do that? How does traceroute know that there's 9 routers between me and the remote host? And the way traceroute does that is, remember we talked just for a second about that time to live. And if you know something about IP, you know that every router that processes a packet reduces that TTL by a value of 1. Well, if I'm traceroute and I know that every router is going to reduce that value by 1, then the first thing I'm going to do is send a packet out to the target that you've specified with a TTL equal to 1. So the first router that gets that packet is going to reduce that value by 1, which is going to turn it into 0, which is going to make that router send you an expired packet. And of course, you as the host that did the original trace route, you get this expired packet, and it of course has a source on it. So you know that the device or the router that responded to that first packet that had a TTL of 1, you know that that's your first hop, and you know what his source IP address is. So then you send a TTL of 2, and you can find the second router and the third, etc., until you get to the target host itself. Path ping does the same thing. However, it sends a lot of ICMP packets to each host along the way to give you a very large sample. And by giving you that larger sample, when it comes back and says, well, here's the latency I measured for each hop along the way, path ping's actually telling you, giving you a much better estimate. So thanks for the question on path ping. Yeah, and for all the ICMP commands, Kevin, I'm just responding to a question from Kevin Crawford. For all the ICMP commands, you can specify a wait period. So for ping, that's as an example, if you're testing the network latency, you can shorten or increase the amount of time that these commands wait for that response. Now, if your question is about path ping, no, I don't believe you can set the interval. Yeah, and Bradley makes a good point. Although there are tools to avoid this by elevating the QoS level, but be careful when you are running a ping command or a traceroute and you are doing it from your home, let's say, because your home, and I'm just using that as an example of a carrier, Time Warner Cable, for example, they may be suppressing ICMP packets, giving them a very low priority at the bottom of the quality of service food chain. And so if you get very poor results, your network may actually be fine, but because those ICMP packets are being squelched, you may get poor results for ICMP, even though every other protocol on your home network is working fine. Tim, yes, all my notes, as well as the slides, etc. I'm going to make everything available, including my email address. If there's something that I just didn't make clear, or something I need to go over again, I'm gonna make myself available for that. So, by the way, and again, thanks for the path ping question. These are the results from path ping. Can everyone see these? You can use that agree, or just type yes, whatever works for you. But very similar to traceroute. It's showing you each hop along the way. It's giving you a round trip time to give you kind of an estimate of latency. But, oh, everyone's saying no, okay. Okay. Sorry about that. Okay, I've reattempted to share the screen that has the path ping results on it, so I'm hoping that comes through now. So again, very similar to traceroute, really the same information, worded a little bit differently. The amount dropped is added, but it's what path ping is doing that's different. By sending 1,000 ICMP packets, let's say, to each host, you get a much larger sample of how that leg of the overall route is performing. And so you get a better estimate of how your network is performing in that particular segment.